channel. In this video, I'm going to teach you how to write formulas for chemical compounds. But before we get to that, there are some terms you need to understand. The first term you need to understand is what an ion is. Well, an ion is an atom or group of atoms with an electric charge, which may be positive or negative. However, when the ions are in a group, they are called radicals, not ions. Another term I want you to get familiar with is valency. Now, valency is a term used to describe the combining power of an atom. And another term is oxidation state, which is really just the valency with an electric charge. So an oxidation number or state is a valency, but with an indication to show that it's a positive or negative charge. Valency has no charge while oxidation numbers have charges. They both help in constructing the formula of a compound. Now, before we get to constructing the formulas of compounds, I want you to take a look at this table, which shows the oxidation number of some elements or and radicals and the groups which those elements belong to with that particular oxidation number. Now before you is a table which shows oxidation number of some elements and radicals and groups which some elements belong to in the periodic table. Here I just focused on group 6, 7, 1, and 2, and 3. So why did I add groups? Here is a tip. If you know the group of a family of elements, it will help you to determine the oxidation number or valency, which is very useful when writing formulas. Now, a brief breakdown of this table is we have our oxidation numbers here and the elements which have these particular oxidation numbers. We have radicals which have also the oxidation number, and finally we have groups which the elements belong to in the periodic table. Now, I highly recommend you memorize some of the common ones which I listed out here. I have oxygen, sulfur, fluorine, chlorine, bromine, iodine. Now, please try to memorize this, that this family I'm highlighting right here, this family of elements called the halogens, they are found in group 7 of the periodic table and their oxidation number is -1. Memorizing this will be very helpful when you are writing formulas for chemical compounds. Uh, for the elements that have oxidation numbers +1, we have hydrogen, sodium, potassium, and for the ones that have +2, we have magnesium, calcium, and for +3, we have bromine and aluminium. Be sure to take note of this. Now, for radicals, these two radicals have their oxidation number as -2. These three have their oxidation number as -1, and this one has its oxidation number as +1. Now, let's get into the writing of the chemical formulas themselves. Now I'll show you 5 simple steps to follow when you are writing the formula of a chemical compound. First step, write the symbols of the elements or radicals that are combined. Let's first of all take this example. If we are asked to write the chemical formula for calcium oxide, like I said before, the first step is to write the symbols of the elements or radicals that are combining. So from calcium oxide, we know from the name that it consists of calcium and oxygen, which you can see on the screen. We have the symbols of calcium and oxygen. So the second step is write the oxidation number of the elements or radicals involved above them to the right. Now this is an instruction. We are supposed to write the oxidation numbers. Now let's take a look back at that table I drew before. We have the oxidation number of calcium as positive 2 and the oxidation number of oxygen as negative 2. So we are going to impute those oxidation numbers above the elements to the right. So calcium has positive 2, we're going to write that, I'm going to write that there. And oxygen has negative 2 as its oxidation number. Now let's go to the third step, which is exchange the oxidation numbers but write them below towards the right of the symbols. That is, we are going to exchange the oxidation numbers of calcium and oxygen. So this will come here and this will come here. And so we'll have something like this. Ca2 minus and O2 plus. Now for the first step, omit the signs, meaning that we are going to remove the positive and negative signs from the number. So we'll have Ca2O2, and this is the formula for the chemical compound. But this is not the proper way of writing it, which leads us to the fifth step. Divide through by a number which can divide all numbers in the formula without a remainder. Only do this now when necessary. So we are going to divide these two, since they are both the same, by a number that can divide them without a remainder. And the number we're going to use is 2. So we're going to divide both sides by 2. So we divide here by 2. The 2's will cancel out and hence we'll have CaO. And this is the formula for calcium oxide. Now that we've known the steps, let's move on to another example. Now let's try writing the chemical formula for sodium hydroxide. Now, no, sodium hydroxide has, from the name, it has sodium and the hydroxide radical. We just done step 1. Now we're going to move over to step 2. Write the oxidation number of the elements or radicals involved. Now, if you go back to the table, you'll see that the oxidation number of sodium, you can see it here, sodium, the oxidation number is +1, and the oxidation number of the hydroxide ion is -1. So if we impute that here, we'll have Na plus and minus. When it is +1 or -1, it doesn't matter if you put the number. You are free to omit the numbers in the case where they are 1. So next, we are going to exchange the oxidation numbers. So this will come here and this will come here. And we'll have something like this. And next, we are going to omit the signs. So we'll have NaOH, and this is the chemical formula for sodium hydroxide. Now for the fifth step, we don't need to implement the fifth step in this case because we have 1, 1, 1 for all the elements involved. So they are already at the lowest term and they are all, balanced. Now let's try another one. If we are asked to write the chemical formula for sodium trioxocarbonate 4, for instance, pardon me, sodium trioxonitrate 5, we know that from the name, the compound includes sodium and the trioxonitrate 5 ion. And from our table, we can deduce that sodium has an oxidation number of +1 and the trioxonitrate 5 ion has its oxidation number at -1. So now we are going to exchange, pardon me, I forgot to add my plus sign. We're going to exchange the oxidation numbers, and plus will go there and minus will come here, and we'll have something like this, Na minus, and we'll have NO3 plus. Now I'm putting it in a bracket because the positive sign is affecting everything in in the brackets. Like in math, we'll have something like 2, then the brackets x plus y. This whole bracket is taken to be like a single entity that is attached to these two, and that's how it is in this chemical formula. The positive sign is affecting everything in the brackets, but since the positive sign, the number attached to it is 1, 1 multiplied by everything in the brackets will still give you the same thing. So when we are omitting the signs, we are going to remove the brackets. So we'll have NaNO3 as the chemical symbol for this compound. Now see if you can write the chemical formula for this compound yourself. If we have calcium hydroxide, for instance, and we're told to write the chemical formula, we'll have from the name Ca and OH, calcium hydroxide. And from the table, we know that calcium has an oxidation number of +2. and hydroxide has oxidation number of -1. And back here, um, if we follow the steps, we are going to have to write the oxidation numbers. Now I want you to take note. In the table I gave you, I wrote +2, and here we are having 2 plus. The reason is that oxidation numbers and um, ionic charges are two different things, although they are very similar. This is how you write um, the ion of a compound. You write the number first before the symbol. And for oxidation numbers, you write the symbol first before you write the number. Take notes. So when you are writing formulas for chemical compounds, you be able to do this. So for the next step, we are going to exchange um, charges. So we'll have Ca minus and OH all in the brackets 2 plus. Now this could multiply everything in the bracket, but since in chemical compounds their formulas are usually written in a simple form, so that is what we are going to do here. We're going to leave the bracket as it is, and we are not going to go into the fifth step. So we'll have Ca brackets OH 2, and we can't divide by anything because there is no common, no something common that can divide through. Like for calcium we have 1 here, and OH we have 2. There is no number that can divide both sides and still give a whole number, so we're going to leave the formula as it is. Still try to attempt this one yourself if you can. Let's say we are asked to write the chemical formula for tetraoxosulfate 6 acid. So we're going to follow step 1, writing the symbol of the elements or radicals. Tetraoxosulfate 6, it has a tetraoxosulfate 6 ion. For the next step, we are going to exchange. It's a positive sign. We're going to exchange. So we have H2 minus and SO4 plus. And since the number attached to this plus is 1, and when 1 multiplies everything in the bracket, is going to still be the same, what we're going to do is that we are going to remove the bracket. So we'll have H2SO4 as our tetraoxosulfate 6 acid. Let's try another one. Let's say we have to write the formula for lead nitrate. Lead 2 triaxonitrate 5 rather. We have lead from the name lead 2, so we'll have 2 plus and triaxonitrate 5 ion. Now we're going to switch um, the oxidation numbers, or the charges rather. We're going to switch the charges. So this will come here and that will come here. So we'll have lead subscript, a negative sign, and NO3 in the brackets, then 2. 2 can multiply everything in the bracket, and when 2 does that, it's going to change what's inside. So we are going to leave the 2 as it is and omit the signs. So we'll have lead nitrate. And for the next one, I want you to try to do this one yourself. Feel free to even rewind and try previous examples yourself. The next one, we are asked to write the chemical formula for aluminium tetraoxosulfate 6. First of all, follow the first step, write the symbols of the elements or radicals. We have aluminium, and tetraoxosulfate 6 ion. The charge of this aluminium is 3. If you check the table, we'll have 3 plus here. Next, you're going to switch. So we'll have Al2 minus SO4 in the brackets 3 plus. Now we are going to omit the signs. I will have something like this: Al2 SO4 3. Now we won't divide in this case, which means we will not be following the fifth step because it's not necessary in this case, because 2 and 3 don't really have anything in common that could divide them both to give a whole number except 1. But when you divide by 1, it will still give you the same thing, so there's really no need. So now, as you can see on the screen, we've successfully written the formula for aluminium tetraoxosulfate 6. Thanks for watching this video. Please like, share this video with others, and subscribe also, and tell your friends to subscribe too, so this channel can grow and get better, and I'll be able to upload better content for you guys. Thanks for watching.